This is section 5.2, example 5. It's the one with the runny nose and the sore throat. There are 29 students in Mrs. Bush's 6th grade class. On a cold winter day in February, many of the students had runny noses and sore throats. After examining each student, the school nurse constructed the following table. Round the answers to 4 decimal places as needed. So this one's nice that they give you all the information in a table instead of just scattered around in the paragraph here. But there's still an additional thing that I like to do with these kind of problems because you almost always need some of these totals. So for runny nose, all the totals of those, whether they had a sore throat or not, there were a total of 20 people with a runny nose and 9 people with no runny nose. And then looking down the columns, 11 had a sore throat and 18 had no sore throat. We could get the total in either direction and it should add up the same. 11 plus 18 is 29. And also 20 plus 9 is 29. Got the same total both directions. That's good. And that also matches how many total students there are supposed to be according to the problem here. Find the probability that a randomly selected student has a runny nose. So runny noses, we've already got our total is 20. Probability is part divided by the whole. So 20 students with runny noses out of 29 total students. 20 divided by 29 is 0. What do we want? 4 decimal places. 0.6897. And so that would be the answer to part 1. Part 2, find the probability that a randomly selected student has a sore throat. All the students with sore throats are here, 11 total out of 29. 11 divided by 29 is 0.3793. Find the probability that a randomly selected student has a runny nose or a sore throat. So we want all the runny noses and we want all the sore throats, but we don't want to count anybody twice. So the most straightforward way to do this are not to use the totals, but to use the individual boxes. So 3 with a sore throat, 8 with both, and another 12 with a runny nose. So 3 plus 8 plus 12 for a total of 23 students that have either a sore throat or a runny nose. And then we're going to divide that by the total, 29, to get 0.7931. And just in terms of order of operations, the reason I had to add them all first and then divide by 29, if you wanted to do it all in one line, you'd have to put the addition part of it in parentheses. Otherwise, it will only divide the last number by 29. So just to show you real quick here, another way you could do that is open parentheses 3 plus 8 plus 12, close parentheses, divided by 29, and you get the exact same answer. Whereas if you did 3 plus 8 plus 12 without parentheses and divided by 29, you get a completely different and wrong answer. So anyway, that was part 3, probability that they have a runny nose or a sore throat. Add up the sore throats and the runny noses without counting anybody twice, and you get 0.7931. Part 4 is the probability that a randomly selected student has neither a runny nose nor a sore throat. quickest way to get here is to find the number of students that have neither, and that's just this 6 right here. The 6 lucky students with no runny nose and no sore throat, divided by the total. 6 divided by 29 is 0.2069 after we round. And that's all for this problem.